Assalamualaikum and a very good day to everyone. My name is Muhammad Amir Iskandar, the group leader of Group 4 from Section 11 BIC 10103 Discrete Structure. We will be presenting our project titled Optimizing Tourist Attraction Visits in Malaysia and Analysis of Minimum Path Linking through Hamiltonian Cycle. Here we have six crew members, including myself, Wong Lik, Hemasri, Osama Jalad, Haris Idlan, and Nitya Sri. Each member has contributed in helping the success of the project. There are four main agendas that will be presented. First is the project background, which includes the introduction and problem background. Next is the project methodology, which includes the approach and code implementation with demonstration. After that, we have results and discussion, and lastly is the conclusion of our presentation. I will start with the introduction of our project. Malaysia is renowned for its expansive landscapes, abundant with rainforests and towering mountains, as well as its diverse cultural heritage, making it an attractive location for vacation. Because of that, the majority of tourists originate from nearby nations like Singapore and Indonesia. Now, an increasing number of international tourists are exploring this country. As the tourism industry seeks to optimize the experience for tourists, there are challenges of efficiently organized attraction visits. Thus, our primary objective is to analyze and construct an appropriate discrete structure-based mathematical model for identifying the minimum path linking tourist attraction visits in Malaysia through a Hamiltonian cycle and interpret the solution using programming code language. Next, I will hand over to Hemasri to explain the problem background.
Hi, I'm Master Munandi. I'm going to explain about our project background. As we know, Malaysia is a popular destination known for its iconic cities, historical location, and breathtaking landscape. The country attracts visitors from around the world, implying a rich and diverse array of tourist attractions. The spatial distribution of this attraction and the diverse experience they offer pose a challenge when it comes to planning optimal routes for tourists. This means that the attractions are not concentrated in a single location but are spread across the country. Additionally, the diverse experience suggests that tourists may be interested in a wide range of activity and sites, from urban landmark to historical sites and natural wonders. Combination these points, the problem arises from the need to efficiently plan travel routes for tourists who want to experience the diverse offering of Malaysia. The challenge is to create a tour itinerary that allows visitors to cover a wide range of attractions considering their scattered location. While also providing a variety of experience, this involves optimizing the sequence in which these attractions are visited and determining the most efficient way tourists to move from one location to another location. A group of tourists landing in Kuala Lumpur aims to visit every tourist attraction in Malaysia exactly once and return to Kuala Lumpur, covering the shortest possible total distance. This scenario presents a challenge in planning an optimal route, considering the diverse attractions spread across the country.
Assalamu alaikum, I'm Osama Abdul Ghani. We are group number 4. Now I will continue explaining our project. This slide displays some information about the project. The Hamiltonian cycle is chosen as the mathematical model using the idea of discrete structure. To determine the shortest path, evaluation of Bayesian routes and total distance of the January and the instructions between each location is considered. Utilization of graph-based models using indirect graph as employed to depict the path from Kuala Lumpur and traverse all select location and come back to Kuala Lumpur as the end point. Finally, not only provides optimal solution to the problem, but also demonstrates its efficiency in identifying a route that visits each attraction exactly once. In this slide, there is a map of the cities that pass through the graph, and there are 2 points that I will explain now. Firstly, an indirect graph is implemented to represent the possible routes starting from Kuala Lumpur and ends in same point, Kuala Lumpur. Secondly, the route encompasses a total of 9 locations. In this slide, the list for the cities starting from Kuala Lumpur, Malacca, Balu Tiamun, Tamanjera, Balu Ridang, Balu Berhantine, Langkawi, Penang, and Cameroon. In this slide, there is a graph that shows the distance between the cities. Starting from Kuala Lumpur to Cameroon, there is 205.3 kilometers. From Cameroon to Penang, 223.5 kilometers. From Penang to Langkawi, 119 kilometers. From Langkawi to Tiamun, 625 kilometers. From Tiamun to Malacca, 223 kilometers. From Malacca to KL, 148 kilometers. From KL to Ridang, 328 kilometers. From Ridang to Tamanjara, 129 kilometers. From Ridang to Berhentine, 33 kilometers. From Berhentine to Tamanjara, 129. From Berhentine to Langkawi, 356 kilometers. From Berhentine to Penang, 260 kilometers. From Berhentine to Cameroon, 218 kilometers.
So on this page, we have three possible roads that we transform from the graph model into this table. So all of these possible roads we taken into account from its geographical location and also distance. So first of all, we have the first road, we starting from the KL, going to Melaka, Pulau Tioman, Taman Negara, Pulau Redang, Pulau Perhentian, Langkawi, and after that Pulau Pinang, Cameron, and KL at the ending point, which the total of the distance is 1727.8 km. And for the second road, we are starting from the KL, Melaka, Pulau Tioman, going through Langkawi, Pulau Pinang, Pulau Perhentian, Taman Negara, next to Pulau Redang, Cameron, and KL with a total of distance which is 2169.9 km. And for the last road, we have KL going through Melaka, Pulau Tioman, Langkawi, Pulau Perhentian, Taman Negara, Pulau Redang, Pulau Pinang, Cameron, and at the ending point is KL with a total of distance which is 2390 km. So all of these three possible roads we are showing in this table to show that which of is best route that suitable for the traveler. So continue on this page. So for this part, all these three possible roads, all of it must have 9 locations, which is at each destination must have been going through once, and the starting and the ending point must still be the same, which for our case is Kuala Lumpur. So because our location have a 9, so that's why the vertices and also the edges must also be the same amount with the location, which in the total of 9 also. So for the first possible of road, we have with a total of 9 location vertices and also 9 paths or edges. Second goes to the 2 possible road, we have 9 location vertices and also 9 paths edge. And for the last possible road, with the same amount width of 9 location vertices and 9 paths. So our purpose is that we want those travelers to go in through all location in Malaysia which have been selected, which of it is once, and the starting and the ending point must still be the same. Hence, by implementing Hamiltonian cycle method, we can identify the shortest and minimal road to travel across the Malaysia. So by providing this graph, we have identified which is the suitable road that is the best for this type of problem. So as you can see on the provided graph, we have identified all those vertices, which is starting point is from KL going through Melaka, continue to Pulau Tioman, next to Taman Negara, Pulau Redang, Pulau Perhentian, Langkawi, Penang, our second last location Cameron, and our last location which is KL is same from our starting location. So as we can see, all those vertices have been going once, and the starting and also the ending point is still the same planes. By then, our best road, which is the first proposed road, is the best and suitable road to be taken. Meanwhile, for the other road, we have taken into account which is not suitable because those vertices will not be going through the rule, which it will going through the vertices twice or for the fourth time, and also the starting point location and the ending point location will not be the same. So this is the solution that we can provide based on the calculation and also investigation on this problem.
Hi, I'm Wong Lek. I'm here to present for the live demonstration. So, for this web page, we are using HTML code, CSS, and JavaScript. At first, the code start with a simple CSS, and here the HTML code defines the web page title Malaysia tourist attraction routes. From here, um, the page includes a responsive table displaying tourist attraction routes in Malaysia, and each of the route is presented with a route number, distance in kilometer, and a sequence of location forming the path. The table has a hover effect for better user interaction, and there's a button label with a calculate shortest path, and it is designed for a visually appealing appearance. And here the result will display at the result section with the ID result. So for the JavaScript code, um, it defines a function name called calculate shortest path. When it is triggered by a button click, it computes and identifies the shortest tourist attraction route among the three predefined routes. So the routes are represented as an object with route numbers, distance, and details path. The code use the reduce function to find the routes with a minimum distance and then update the HTML content in the uh, ID result section to display the information like the shortest path and is including the route number, distance, and the complete sequence of the tourist attraction along the route. So let's see the web page. So for the web page, it has the title Malaysia Tourist Attraction Route, and then it has a table with three predefined routes, and then there's a button calculate the shortest path. When we click on the button, it will display the output. And then for the output, it display the route number, the distance, and the complete routes. So that's all from me. Thank you.
Hi, my name is Ritya Sripanesarum. I'll be talking about the results, discussion, and the conclusion. The results of this study is that the application of the graph-based models and programming code implementation has a great result. In the optimization of all possible routes is conducted through Hamilton cycle methodology and ensures that each tourist attraction visits is visited exactly once. Route 1 is proven to be the most efficient and it covers all the destination while minimizing the distance and the time travel. So the discussion of these studies is that while Route 1 is most optimal route, it is crucial to consider the various factors which are road condition, traffic patterns and transportation option. The Hamilton cycle not only provides visual deception of the optional journey, but it also gives a strategic order of the location of visitation. In conclusion, we can give the Hamilton cycle that it gives a better result to find the optimization of the tourist attraction visits in Malaysia through analyzing the minimum path, which allows the tourist to travel all the attraction location without skipping any location exactly once. It also gives guidance to the tourists that they can plan their journey ahead to visit all the attractions in Malaysia. So that's it from our group. Thank you, everyone.